So obviously, let's type this into our calculator unless you feel like you got this all figured out. But if you wanna, from time to time, I kind of give you some helpful tips. Or so we enter this into our y1 and you graph it, and chances are that my window is way off. Yeah. So I'm just gonna go zoom 6. That's what I do. And okay, so it's not bad. I can see the x-intercept almost. So I'm just gonna increase y max, x max, right? So y max, I'm thinking 35 or something. We'll see. There we go. So that's perfect. And remember, this is a word problem, so we were kind of restricted to quadrant 1. We can only have positive time. And the implication is that when it hits the ground, then it kind of, the model stops, right? And so we've got that figured out, and it says how long will it take for the ball to hit the surface of the moon? So it's launched, right? And then it hits the ground right here at the x-intercept. So the expectation is moving forward that you tell me the keystrokes, right? You tell me like this is what I pressed. If it's not exactly like this, that's okay, as long as you somehow indicate what you did, okay? But you'll see that from overall, it's fairly straightforward to show that. So I need to find the x-intercept. I let y2 equal to 0. I wait for it to graph it. I don't care about this one because the action starts right here where time is 0. So it's this point that I'm interested in. So you kind of have to go as close as possible to that one. As soon as you're over the hill, it's all right. All right, here we go. Enter, enter, enter. And there we have it. It's 10.120. You write down the coordinates, and then you say it will take 10.12 seconds. I saw a lot of that, so that's good. What's the maximum altitude the ball reaches? Obviously, we're talking vertex, right? So I'm going to say second trace max, right? I'm just going to say something here. You kind of expect, based on the context, that the ball is going up and then hitting the ground, right? So it should be pointing down. Some students forget to type in the negative, and they're sticking with the whole parabola pointing up, and I'm like, at some point it should have dawned on you that it's probably not the case, right? So just keep that in mind. Use common sense. So I'm going to use the max. Go find it, right? So you got to go to the left of it. You go to the right of it, and you get 4.23, 24.68. That would be the coordinate of the vertex, but the maximum height or altitude is this. Okay, maximum height is 24.68, and we are in meters. So that would give you a full mark if you state the coordinate and then tell me that which one of these two is actually referring to the height. It's the y value, right? Initial height of the ball, it's in general form. Yeah. I would say only half a mark for the whole page. So if you missed it every single time, just take off maximum of half for the full page. Yeah. And this is what I normally do, right? If you see K circled, right, that's keystrokes, rounding, units, notation. So if you forget equal signs, that's a big one. Even in grade 12, if you're in a bit, we're going to write the equation. You need to have a letter equals, right, and then whatever follows that equal sign. Okay. Okay. What's the initial height of the ball? And it's in general form, so I can just say 0, 12 is the coordinate of that y-intercept. So initial height is 12 meters. Half a mark for that one. Right there. D, sketch this. When you sketch, please just find all the intercepts, and quite often at this point you already know them, right? So intercepts and vertex, like that's like I would say that's a must for you to be able to graph properly. So I'll go time in seconds. This is the height in what? Meters, right? So don't just write down height, write down and in meters, right? And then I need an appropriate scale. So the furthest I go is 10, 12, right, for my x-intercept. So let me see here, 2, 4, 6, 8. That's a little bit. So I'm going to go up by, I'm going to make this 2, 4, 6, 8, 10. It's a little bit compressed, but it will do. It will do. So this is 12 here. So if you do this, I would appreciate you being very specific, like highlight the markings, right? Like that's the 12 goes with this line right here. That would be great. And then my height, I go all the way up to 24.68. That's based on the vertex. So I need to see 5, 10, 15, sorry, 5, 10, 15, 20, and this is 25, right? So I'm going up by 5s. That's what I chose. You don't have to. You can make every box worth 1. Just make sure it fits, okay? And we have 0, 12. This is 12.5, so 0, 12 is right about there. 10, 12 is right about there. And my vertex is at 4.23. 24.68, which is right about there. So then you go up, over, and your graph may look a little different because you chose a different scale, so you kind of make it wider, not a big deal at all. And so if you want the full marks, you need to have your equation with it. Okay. So shape, scale, all that. Let's make this worth 3. I would say scale is worth 1 mark. So each axis is half. Labels would be worth 1 mark. And then the actual shape and points, right? Like actual having the points where they're supposed to be, I would give you a mark there. So if the points aren't where they're supposed to be, if it's way off, I do notice that. If it's off by a little bit, I quite frankly am not gonna like hone in on that, right? So just approximately that is that. Okay, so that's your graph. 3 marks for that. The domain and range, you choose which one you want to use, which format. So for the domain, we usually go D, and then if you want to use interval, it's from 0 to 10.12, right? And your range would be zeros included, right? Because it does touch the ground all the way to the highest point, which is 24.68. So you get 1 mark for each correct domain and range. Anybody use set notation? If you use set notation, you have to be careful. It can cost you, right? Because it would be like this. For the domain, you have to use the letter T. Okay, because because the equation uses T for X, right? And so that would be like this. And squiggly brackets, right? And the range would be 0H to 24.68 if you have it like that. says how long is the ball at 17.5 meters or above. That calls for drawing that line and then going second trace 5. And let's see here. So you go and graph it. Y2 is 17.5. They're essentially giving you the Y value, right? And so we're going to graph it. And there it is. And it happens twice, right? It reaches that height on its way up and back on its way down. So we want to know the time that elapsed in this stretch right here. So second trace 5. I'm going to find my first time on its way up is 1.0462. Time 2 is the other one. So I'm going to go find that second. Right? 7.4045. So I would say this right now, you would get half a mark for each, right? So if you found that one and you found that one, you get half and half. Then to get the other half mark, you go time 2 minus time 1. Okay, so that's 7.4. Yeah. If you round it too early here, you round it to 2 decimals. Just half a mark deduction for the whole thing. Except for, hold on, except for, that's where I give you the benefit, right? So I'm basically taking these two values here, and let's see what you get. I get 6.36 seconds. Is that what you get? 3.5? Yeah, then I take off half a mark. If you, sometimes rounding early here does not affect the final answer, then I just don't worry about it. Then I'm assuming you used all decimals. But since it did affect it, then you lose half a mark. This is usually a 2-mark question, by the way. You get half, half, and a full mark for subtracting. But for today, we're just going to leave it at that. So we are out of 9, right? This is out of 9. Because of the graph being changed to 3, we're going to make this out of 9. Okay. All right, so name and last name, which was already on there, that's all good. And face it upside down and pass it forward. And get your notes out.